All right, welcome back to your final lab for summer session 2, and we're going to take a look at fluvial geomorphology. Um, this lab is usually done in person. There's a video that I advise you watching that's within the PowerPoint for this lab module, where it shows the actual students and Dr. Townsend going out to the river and doing some measurements, including using the little rubber ducky here fellow in this stadia rod to measure depth and width, and they do it at the San Marcos, right outside of Kirby Lane, is where they measure the stream river discharge and get these values from. But let's take a look at a few of the examples and walk you through some answers here. And the first thing is this is a document within the module, and so you'll want to download this file, and it gives you all these measurements from previous labs that have been out there. Obviously, this is an asynchronous online course, so you're not going to go out and do this lab yourself. So these measurements are provided. So first question is asking, what is the river width? And so identify in the material provided here where the width is. There you go. Pretty simple. Get the ball rolling, nice and easy here. Question 2 asks you the average depth. I apologize if my little the camera is in the way there, but the average depth, you'll need to look at all of those depth measurements across that they took with the stadia rod across the where they measured the width. Add them all together and then divide by 10 and get your answer for that. And you can add, subtract, divide, and multiply. This lab's going to be a breeze from you. Just take your time to make sure you're reading the instructions for what to do for each part in good detail. All right, so question 3 is one of these ones that has a little more detail. Calculate the cross-sectional area, and it says A, and so let's look at this figure highlighted there in a red box. That's the cross-sectional area. You need the width and the depth, which you just figured. So you're going to multiply your width times your depth to get another figure. And all of these ask you to round to 2 decimal places. If it's a 0, like in question 1, I put 50.1. That's fine. I look at them all, and if you're close enough, we do our best to get you some points. And so you get the answer to question 3 there at 79.16 for the area of square feet, the cross-sectional area. You'll use this other data for different parts of answering. And so let's just look at that real quick as well. So you're going to need this for this question where it's going to talk about velocity data. And so there's 10 stream flow velocity measurements taken with the rubber ducky, where they track how long it takes to get across in time here, and the distance is all 50 feet. And so the time and the seconds, and so how many feet per second. Again, if you can add, subtract, multiply, and divide, you got this. It's pretty straightforward. So for trial 1, got 50 feet divided by 50 seconds. So I put a little dividing, give you a numerator and denominator there. Divide those 2 values, and you get 3.37. Again, just rounding to the second decimal place. Do that again for the second one, and you get another value. You're going to do that for all of these 10 different trial runs, and then get a total for that, do an average for it, and then you'll do a little bit of work with these flow meter measurements down here. You're going to add them together and get an average as well. So add all 3 and divide by 3. Take the total, divide by 3, and you got it. And so good luck with that. Again, email me with any questions, or if you need to meet, any questions about previous labs. If you have any concerns, let me know, reach out. I'm always happy to talk. And thanks for your time. And I hope that you have a good rest of your semester. And I look forward to seeing you around campus if you're around campus this fall. Take care.